welcome back to Geometry, Chapter 4, I said it wrong again, Chapter 7, Section 4. I'm slightly dyslexic and I will not only flip numbers when I look at them, I'll say them backwards too. So, sorry about that. But hey, I overcame and became a math and science teacher. So, you can too. Alright, so we're doing Chapter 7, Section 4 in this book. And what we've been talking about, and the reason why the board is so colorful, is we've been talking about transformations. And that's just a fancy math word for taking a shape and sliding it to another place, or flipping it or rotating it, but moving it to another place. And what makes it hard is, one thing is that we have two words that are big and don't really describe what they're talking about that start with the letter T. And what we're talking about today is translations, which are a type of transformation. And what it means is we're just sliding the shape from one place to another. We've talked about flipping it, which is a reflection, and we've talked about rotating it, where it's like it's got a push pin stuck in it and you rotate it around, or the push pin's on a piece of string and it's on the end of the string rotating around. But today we're going to talk about translations and also a part that overlaps science called vectors. So those are the two things we're going to talk about. Now, translations, where you take a shape and slide it somewhere else, are isometries, which means, if you remember, iso means same, metry is like measurement. It means they are the same size and the same shape. Later on, we will talk about what if you enlarge it, what if you make it smaller, and those are called similar shapes. These are not similar, these are exactly the same because they're the same size and shape, so they are isometries. We're just moving it somewhere else. So here's an example. We have this blue line PQ and we slide it down to the red line, which is called P prime Q prime. And we just slid it down. These black lines are just showing the path of sliding, and that's what that arrow is showing too. And there's a couple of things we know are true because this was a translation, a slide. First of all, that if you connected P to P prime and drew a line, and you connected Q to Q prime and drew a line, those lines would be parallel. That's what those triangles mean. And they would also be the same length. That's what those little red lines mean. So PP prime equals Q prime. They're the same length. And P prime is parallel to Q prime. That's what those arrows mean. Also, P prime and Q prime, you can connect them with a line so they are collinear. There's a straight line between them. Okay, so here's our next thing. And it is that if you take this blue line and you flip it over K to make the red line, and then flip it again over the black line M to get the green image. So we went from pre-image to image to another image, our final image. We flipped it twice. That it's the same thing as if we just slid it. See, we could have just slid the blue one down to the green one, or we could flip it twice. It does the same thing. Reflect then reflect equals a translation, which is a slide. Okay, so and there's a few things we can know about this. One is P to P prime is perpendicular, see the little perpendicular sign, the right angle sign, to K and M. So if we drew a line from P to our final image P prime, it would make perpendicular lines to the lines we would have flipped over if we did the flip thing, okay? The second thing is, if we measured the distance, see that big green D? If we measure the distance between K and M, it's equal to the distance between P and P prime twice. So you can kind of imagine it. You see how big this is, and if you took that plus that, it's the same thing. So from the distance between these lines is the distance between the points. So it's the distance between P and P prime. And also you could measure it up here. It's the distance between Q and Q prime. So the distance between the flip lines is, you double it and you get the distance between the points. Now, so for example, if we connected our Q's, and this line from Q to K is 5, And this line from M to Q double prime is 2. How big is the whole distance? Well, we know what's on the outside is equal to what's on the inside. That this 2 is the same as that 2, and this 5 is the same as that 5, right? And 5 and 5 and 2 and 2 is 14. So we know the distance here is the same thing, it's 14. From P to P prime is the same as from Q to Q prime. Red line, they're equal to each other. And then the other thing is what in this is congruent? Which lines are congruent? Well, we can see that this line is the same as that line is the same as that line, this line is the same as that line, this line is the same as that line. Okay, also, look, I'm running out of things, but this line, 1, 2, 3, 4, 5, is the same as 1, 2, 3, 4, 5. And because this makes a rectangle right there. And also, of course, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, all of those are equal to each other. Our sticks are the same length because this is an isometry. All right. Here's now another way they write these things. Here I have this line, PQ, Q is at 1, 2, P is at 2, 4, and I'm going to draw a red line, and this is telling me how to do it. It says to X, I'm going to add something, and to Y, I'm going to add something, and what they want me to do is to X, they want me to add 4. So, my X is 1 here, 1 plus 4 is 5. 1, 2, 3, 4, 5. And to Y, they want me at minus 2. 2, I didn't draw that right. There should be another one right there. Because Y is supposed to be 2, and I only have it at 1. I went, X, Y. X. I think my dot's at the wrong thing. X. No, my thing's at the right thing. It's right there. It's over 1 up 2. And now what I'm supposed to do, okay, so I do X plus 4 is 1 plus 4 is 5, and Y minus 2, 2 minus 2 is 0. So my point here is going to be out 5, 1, 2, 3, 4, 5, up 0, I'm getting a dot right there. I think my red marker is running out. Let's get another one. Okay, so this new point, which is Q prime, is at 5, 0. That's a much better marker, isn't it? Okay, and now we're going to do P. We add 4 to 2. 2 plus 4 is 6. So for 6, that was 5. This is 6. And for Y, I do 4 minus 2. 4 minus 2 is 2, so I go up to 1, 2. This is a little hard to see. It would be right there. Whoop. And there is how I moved it. So this one was, this point up here was 2 plus 4 is 6. And 4 minus 2 is 2. And that's where it is. You can see this drawn better in your book, but sometimes they're written like this. Now then, here's another one. Here I have this triangle, and they want me to change each of the X's by doing minus 3, which I did, and all the Y's add 4. So negative 1 minus 3 is negative 4, and 3 plus 4, negative 3, that's a negative 3, it looks messy. Negative 3 plus 4 is 1. So I just do the math to all of your ones, get what the new ones are, and then you can find where your prime would go. So it's at negative 4, 1, 2, 3, 4, positive 1 is my A. There's a dot right there for A prime. The next one is negative 2, 3, 1, 2, 3. We'll put a dot there for B prime. And C is negative 4, 1, 2, 3, 4, 4. 1, 2, 3, 4. C prime, and here's my triangle. It got slid up and over. It got slid back 3 and up 4. And if this was on graph paper, you could tell they're the same shape. But, you know, I just sort of eyeballed it and obviously didn't do too good. All right, now vectors. How I teach this in physics is I get a kid who's sitting right here and me, and we grab hold of the marker and I say, I want you to pull it toward you and me to pull it toward me, and not too hard so ink doesn't go everywhere, and we'll see where it goes. And when the kid pulls it this way and I pull it straight toward this, it goes in between us. Well, so forces, like pulling on a marker, can have components. It didn't go all the way to them and all the way to me. It went somewhere in the middle. So this is sort of what we have going on here. One person is pulling the marker this way, another person is pulling the marker that way, and it goes kind of in the middle. And this one, the one person is pulling with 5 and the other one 2, so it goes sort of like that. The result is it went 5 over and 3 up, but it didn't go at right angles. It goes in a line in between, which is called the resultant. So vectors are a way of showing certain things in physics. They show the magnitude and direction by an arrow. Notice how there's that green arrow there. The magnitude or the strength is shown by the length of the stick part of the arrow. The direction is shown by the arrowhead. So with this marker thing, then it went this way. So my vector would look like an arrow going this way, arrowhead going that way. So each vector can be broken down into its x component and y component. This, from going from the beginning point, which is called the initial point, to the final point, it went over 5 and up 3. The 5 over is the x component, the up 3 is the y component. How you write this vector in component form is you use triangle looking brackets and you put 5 there for the x, the over, and 3 for the y. You do triangle brackets and it's telling me that from where I start, I go over 5, up 3, and then draw the line. It's more